Cornell University has taken the first big step in converting its main campus in Ithaca, New York, from traditional steam heat to low-temperature hot water. The university took advantage of an existing storage space in the Mary Donlin building and dedicated this space to creating a hub that could export low-temperature hot water to nearly 800,000 square feet of new housing and dining facilities being developed on the North Campus. High-pressure steam at 80 psig from the Central Campus piping network enters the lower level of Mary Donlin through a 10-inch diameter steam pipe with a companion 4-inch pump condensate line that returns to the steam plant. The steam enters what is called vertical heat exchangers. There are 3 of them neatly mounted on steel skid here. These 3 heat exchangers take the steam and convert low temperature hot water at 105 degrees to 180 degrees, which is then circulated throughout this building to 5 buildings on the campus. Steam goes no further than this room. The skid is equipped with control valves, transmitters, and a BAS panel. The BAS panel is connected to the Cornell Controls network for monitoring these valves, transmitters, and receiving the status of equipment. These steam valves up top reduce steam pressure to 17 psig, and these traps at the bottom help ensure that all latent heat is transferred to the hot water loop. All this takes place on a 5-foot by 7-foot skid that is no more than 9 feet tall. One of the nice features of this type of heat exchanger is controllability. The control panel reports back to the campus the valve positions, temperature conditions, and equipment status at all times. Hot water is returned from the building loop and is pumped via 3 vertical inline pumps on variable frequency drives through the hot water heat exchangers, which is then distributed to the building loop and the buildings on the loop at 180 degrees. Why 180 degree hot water supply? Cornell wanted to achieve a 70-degree temperature differential to keep a reasonable pipe size. For this size of a development, 180-degree hot water supply was ideal. Distribution piping to the buildings is constructed of EN 253 thin wall steel that is insulated in foam and protected with an HDPE jacket. Thin wall piping is ideal for hot water. It doesn't require a deep burial depth, doesn't require a slope, and doesn't require vaults or manholes. It doesn't need traditional expansion joints either. The shutoff valves are insulated and directly buried. This is a very cost-effective product for running long distances on campuses. The move to hot water means better energy efficiency, less fossil fuels, less carbon emissions, and a pathway to using renewable energy in the future. It's a win-win.